This is a video on the I've Got to Fill In activity, which you previously received in class, and incorporated within it will be a little bit of an algebra review. First thing we need to do is review the three different forms of quadratics that we've studied in class so far. The first one is standard form, which is y equals ax squared plus bx plus c. So a couple different things to note about standard form. First of all, the a in standard form is going to be our dilation factor. This is going to be what our vertical stretch or compression is. It's going to be, making the graph narrower or wider. And we can look at it. It is always the leading coefficient of the quadratic term, which is a. The other thing to note is c. C in this case is always going to be the y-intercept. So if you're ever asked to find the y-intercept and you're given standard form, it's just going to be the number c. The next form we have is vertex form. Vertex form is y equals a times x minus h squared plus k. Couple different things to note about vertex form. Again, a is going to be your dilation factor. So if there's a vertical stretch or compression, then that's going to be a. Another thing to note is our vertex is always going to be hk. Remember that h in this equation will always be the opposite. So if you have x plus 2 squared, h is going to be negative 2. If you have x minus 5 squared, h is going to be positive 5. K will always stay the same though. Our last version is factored form, which is y equals a times x minus p times x minus q. In factored form, this is what we get when we factor from standard form. A is going to be our dilation factor, and P and Q are going to be our x-intercepts. Now you want to be very careful here because your dilation factor in factored form is actually the leading coefficient of the quadratic term. So when you multiply the factored form out, the leading coefficient of the quadratic term is going to be your dilation factor. So we're going to look at an example of this just so I can further explain where you need to be careful when you have factored form. So with factored form, we have y equals a times x minus p times x minus q. One of the things that I want to note is that you have to be very careful. If I ever had an equation, I factored it out, and I have y equals 2, because that was my GCF, times 2x minus 1 times 3x plus 2. Maybe we factored it out, we got this answer. Couple different things to make sure that you're careful about are the x-intercepts and the dilation factor. If I multiplied this out, I'd have y equals 2 times 2x minus 1 times 3x plus 2, which will give me 2x times 3x, which is 6x squared, yada, 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 which will give me then a 12x squared, yada, yada, yada. I don't really care about all the other stuff, but what I do care about is the leading coefficient, because that's going to be my dilation factor. So A is actually going to be, I shouldn't say A. Let me take that back. What I should say is that my dilation factor, or my vertical stretch, equals 12. So please be careful, because I don't want you to just assume that it's A. It's only going to be A if the leading coefficients of each binomial is 1. The other thing to note is that I don't want you to get comfortable saying that the x-intercepts are just p and q, because in this case, for instance, we have 2x minus 1 and 3x plus 2. And it changes a bit because there's a leading coefficient that's not 1. So remember, we have something called the zero product property. Zero product property, or you can call it the ZPP. And the ZPP says that if I have A times B equals 0, then either A has to equal 0 or B equals 0. One of those two factors has to equal 0 for the product to be equal to 0. So if we look at a case like y equals 2 times 2x minus 1 times 3x plus 2, what we see is that we've got two different main factors here. And if this product is going to equal 0, either this factor has to equal 0 or this factor has to equal 0. So remember, an x-intercept is when y equals 0. So what we really have is 0 equals 2 times 2x minus 1 times 3x plus 2. I know I can divide both sides by 2, and I'm still going to get a 0 equals 2x minus 1 times 3x plus 2. What this shows us is that 0 equals this times this. So I can look at 2x minus 1 being equivalent to the A and 3x plus 2 being equivalent to the B. So either 2x minus 1 has to equal 0 or 3x plus 2 has to equal 0. We're looking for all possible values of x that are going to make this product equal to 0. So what I can do is set each of my factors equal to 0 and solve for x. So I'm going to add 1 to both sides. We get 2x equals 1. Divide by 2. X equals 1/2. That's going to be one of my x-intercepts. I'm going to subtract 2 here, and I'm going to get 3x equals negative 2. Divide by 3, and x equals negative 2/3. That's going to be my other x-intercept. Remember that a lot of parabolas cross the x-axis in two different spots. And so that's one of the reasons why we have two x-intercepts. These are all possible values that make my product equal to 0. So just be careful when you're finding the factored form, because if either of these x's has a leading coefficient that's not 1, you have to be a little bit more careful about finding the vertical stretch and the x-intercepts. The other thing we want to look at is how can I, if I'm given factored form, go into any of the other forms, standard form or vertex form. Standard form's pretty easy. All you have to do is multiply it out. But vertex form is a little bit more difficult. So one of the things that we see is we have, let's say we have this graph and we have our x-intercepts. This is x equals p and this is x equals q. All right, one of our things that we know about the x-intercepts is that our vertex is at exactly halfway between my x-intercepts. So my vertex is halfway between my x-intercepts. The other thing I know is that my line of symmetry goes through my vertex. So my line of symmetry must be halfway between my x-intercepts. This is like finding the mean or the average. So I can add up my two x-intercepts and divide by 2, and that will give me the line of symmetry. What that will also give me is the x value of my vertex. So if I want to find my vertex, all I have to do is take my x value and plug it in into my original equation to find the y value that is associated with that particular x value. So my vertex is going to be an ordered pair that's going to be p plus q divided by 2, and then the y value, or f of p plus q divided by 2. This is going to be my vertex. Once I found my vertex, I can put my equation into the vertex form. Y equals a times x minus h squared plus k. So I can put my x value of my vertex where h is, and my y value of my vertex where k is. Now all I need to do is find a. And I can either find that by looking at a graph and determining what the dilation factor is, or if we know another point, I always think the y-intercept is a good one to use. We can plug that point into x and y and solve for a. And then we've got our vertex form. So you'll see me using some of this when I do the I've got to fill in activity. So keep that in mind.